transistor as a switch. Switch now it has a two options. One is on, another one is the off. So now we are going to use the transistor as a switch. So transistor as the dual state, one is the on, another one is the off. So now we are going to see that how that transistor is used as a switch. First thing, presence of DC source at input saturation region. So in that region, is the Vin is the input current which is given to the transistor through the base, and IC is the collector current we can get from the collector. Okay. So initially we are giving that input current for input current. We are giving that input current, it's a high voltage. So we are giving the input current through the base so that that transistor amplify the signal. So that input current is a very high means what will happen? That current is magnified by the collector, and that signal is sent into the that collector resistance, load resistance. So that signal is amplified. So amplified signal is potential drop across the resistance RC. So we are giving the high voltage that is high value. So the current is in the low value. It will comes out output in a low value. So applying that output in a high value, you will get that low value. So it's called the on state. So the on state means that is the reciprocal. So we are giving the high voltage, but in the condition is off state. So it's called the off state. See here, that 5 volt is the applied voltage. The current IB increases. The collector current is increases the collector current. The transistor will move into the on state. So the collector current IC increases, voltage drop across R. So resistance, you know that the resistance has the resistance through the resistance, potential drop across the resistance. So it is that value is given to the RC is lowering the output because it is total potential drop across the load resistance. நம்ம எவ்வளோ அதிகமான இன்புட் கொடுத்தாலும் என்னாச்சு, ஆம்பிளிஃபை ஆன வந்த சிக்னல் வந்து ரெசிஸ்டன்ஸ்ல டிராப் ஆயிடுச்சு. ஸோ இட் இஸ் ஜீரோ. ஸோ த டிரான்சிஸ்டர் இஸ் லுக் லைக் a closed switch. Closed switch means transistor in a on state. The switch closed, but the switch is in on state condition. Like that happens of DC circuit. So now we are not going to give any input to the Vin. So it is zero, or it is a very low value given to the base current. Now that value is amplified and it is given to the resistance RC. So that low voltage is applied here, but it has a very high voltage. So potential drop across the RC. So it produces the current in a off state. See here. So collector current IC decreases. So potential drop across the RC. So thereby that increasing the voltage plus by the transistor in a open switch. So that is considered as a off condition. அப்போ நம்ம வந்து high voltage கொடுத்தா low off காட்டுது, low கொடுத்தா high காட்டுது. So it is a reciprocal. That is it producing the opposite to the input current. So high input and low output gives the high output. So we say that output voltage is opposite to the operating input voltage. So therefore, transistor can be used as an inverter in a computer logic set. So we are using the inverter. Suppose we are giving that on means it will give it is in the off state. Suppose we give the off state, it will produce the on state. So it produces opposite voltage. Okay, so that's why using the transistor we used as a switch. So operating point. So operating point is a point that transistor can be operated efficiently. We studied that output cases. See. So this is the output cases. In this region, it's a cutoff region, and this is saturation region. In between, these regions are called the active region. So in this active region, the transistors are effectively function. So operating point means that using that operating point, we can select the required amount of current and voltage. So the operating point should be in the active region. So here we are using that operating point, or we can select the operating point IC equal to 0 or IC VC equal to 0. Suppose you are putting that line, you will get line like this. So VC equal to VC and VC by RC. So you put 2 dot here and you can draw the straight line. So you will get the line like this. In this line, in active region, you can select the 3 points. The points are P, Q, R. These points are called the operating point. In this operating point, suppose you are selecting the point O, it is centered to the active region. So you can get the clear amplification. So that is the operating point. In that operating point, that maximum signal you can get without any distortion. Distortion means noise. Without getting any noise, we can get the quality signal in this particular point without any distortion. So the transistor works as a opposite for the Q point, that is operating point or position point, or you can call it as Q point. Can be chosen at the cutoff region and that work close switch off. Suppose you are selecting that operating point is here, that shaded region. This region is called the cutoff region. So in that cutoff region, the transistor does not work. So operating point selected in the active region of the output cap. So next thing is transistor as an amplifier. So transistor as an amplifier. Amplifier, you can hear the word. கேபிள் காரங்களாம் சொல்லுவாங்க ஆம்பிளிஃபையர் மாட்டினா டிவியில சிக்னல் நல்லா தெரியும் அப்படின்ற மாதிரி நீங்க கேள்விப்பட்டிருப்பீங்க. ஸோ சிக்னல் வந்து ஒரு லாங் டிஸ்டன்ஸ் சொல்லும்போது செட் பண்ணும்போது என்ன ஆகும் அப்படின்னா that signal strength is decreases. By using that amplifier, you can increase the signal strength. That's called amplifier. So amplification is the process of increasing the signal strength or in the amplitude. So that's called the amplifier. So here the transistor is going to use this amplifier. See that this amplifier circuit is connected that C1. C1 is the capacitor. So this Vs is the input. Input is given to the capacitor. Through the capacitor, we are applying to the base of the transistor. So that capacitor C1 is used for, it will allow only the AC current, does not allow the DC current. That's why the capacitor is connected here. The DC current means direct current, you know that AC current, alternating current. So capacitor C1 allow only the alternating current, it goes the DC current flowing into the circuit. So we are giving that current flow through the base of the transistor. After that base current in transistor, the signal will be amplified. That flow of current is increased in the collector. So the collector current is comes out through this direction. Then R2 are the biasing resistance. So that resistance are allowed a particular current only. Suppose the more current is flowing in this circuit, it will damage the circuit. So here that Re is the resistance connected in emitter. So connected emitter is resistance. Suppose the flow of current is increases, the current is decreases through the resistance, that is potential drop across the resistance. Suppose the flow of current is decreases, that energy stored in the capacitor. So you study in the capacitor in first level. So this capacitor energy is stored. Suppose that the energy is decreases, that capacitor gives the energy to the signal. So it is increases means the resistance Re will decrease it. Suppose it is decreases, that Ce will increase. So you can maintain the same current in this circuit for the base emitter current. So IE is the emitter current flowing in this direction. Then this RC, through the resistance RC, the collector current is flowing through the current through the CC capacitor. The CC capacitor is the collector capacitor. Here again you can connect the capacitor, because the capacitor only allows the alternate current. So that capacitor, the amplifier circuit, again it is connected to the another one circuit. So it is connected in the other circuit. That's why the capacitor is connected in the output device. So V0 is the output. So input signal, this is the AC input signal we are applying to the Vs. After amplification, we will get that 180-degree phase difference. So you know that whether the base current, we are giving the any amount of voltage, the collector is inverted it. Okay, you already put up on the picture, it will convert that, it is reciprocal. So it is maximum means minimum. So when the signal is sent into that amplifier, it's amplified the signal and into the 180-degree difference. So you will get the signal like this. So this is the input signal and this is the output signal. So the phase difference between these two signals are 180-degree. Okay, so it's called an amplifier. So operating point on video is there. First we complete the video, then we go to the. So these are all the things in the operating point. Cutoff region, air saturation, middle, active region. So this is the PQR. PQR of the operating point. In amplifier, the amplifier the signal like this. We are giving the input like this. One out of 180 degrees difference, it will come out like this. See, these two waves are inverted to each other up to 180 degree angle. So using that, you can get the amplifier signal. So this input and this is output. This is the operating point Q. So on the basis of Q, we are amplifying the signal. So this is the operating point. I think in the transistor. So now amplifier. See that amplifier.
In this video, I shall discuss transistor as an amplifier. First, we see what is amplifier.
See, the amplifier. Let's say input signals R1 and R2. It's through the base. The signal is given to the amplifier. It will amplify and it is given to the selector. So here that is emitter current, and the emitter current is passing through the circuit. So here the amplifier signal is given to that selector. So the current is flow from here to that to output. Okay. So input is applied to the capacitor according to the Ohm's law equal to IR. The voltage is increases, but in a collector current, it will decrease the potential drop across the collector for the system. So amplifier means it is amplifying the signal. So whatever the signal given to the amplifier to input to the base, it will amplify and it can get that to the collector. Collector low resistance, but the collector is not here, but our circuit we have the collector. So simple circuit. So this is the input current. So input current is supplied to the base, and out of 180 degree phase difference will come out in the collector. Okay. The amplifier signal is going to the collector. So this is the output. See, say input signal and this is the output signal. Input signal is very small, but output signal is very large. So signal is amplified. So the same phase, but you can see that the phase is here 180 degree out of phase. The first key the negative on the but this is a positive. So 180 degree out of phase. Okay. So it's a so it's the amplifier. So amplifier during the positive half of cycle, negative half of the cycle, how we amplifier is your Next thing is transistor as an oscillator. Oscillator means it converts the direct current, direct current or direct energy into alternate current or alternate energy. So direct current இருந்துச்சு அப்படின்னா alternate current convert பண்றதுக்காக யூஸ் பண்றாங்க oscillator. So an oscillator is basically converts the DC energy into AC energy of high frequency waves. That's few heads to that is megahertz up to megahertz. Oscillator அப்படிங்கிற வேர்டு ஏற்கனவே நீங்க பார்த்துருப்பீங்க. எங்க பார்த்துருப்போம் அப்படின்னா 10th lesson. So it is used as a carrier wave. Signal wave is superimposed on the carrier wave. Carrier wave was produced by the oscillator. That is the oscillator here. So the amplifier is the transistor is used as a oscillator. The oscillators can produce the frequency different. That is alternate frequency. It converts the DC direct frequency into alternate frequency, or the direct energy into alternate. So using that oscillator, we can produce the sinusoidal wave and the non-sinusoidal wave. What is the two different types of waves? That is sinusoidal wave and non-sinusoidal waves. Sinusoidal waves means that waves are in a sine form. See, this is a first wave, sinusoidal wave, sine wave. So this wave is called a sine wave. So sinusoidal wave, sine wave is produced. The wave is called the sine wave or sinusoidal wave. That other waves are, see here is a square wave, another this one is triangle wave, and this is sawtooth wave. These are all non-sinusoidal waves. So sine wave is called sinusoidal wave, other waves are called non-sinusoidal waves. So that using that oscillator we can produce a sinusoidal wave and non-sinusoidal waves. Then again the waves have the two types of waves. Again it can be that oscillation can be again divided into two oscillations. One is the damped oscillation, another one is the undamped oscillation. This first picture shows that the damped oscillation option here. This one is the damped oscillation. See that initially it has the maximum amplitude. That amplitude of the wave is gradually decreases. Finally, it becomes straight line. Okay, so this is called the damped oscillation. That other way you see that there is no change in the wave. See, all the amplitudes are same. So it's called undamped oscillation. So here the damped oscillation, initial magnitude is very high, gradually it is decreases. That means that wave loses its energy. When energy is losses, that the amplitude of the wave is gradually decreases. Finally, it will get zero. So this type of wave is called damped oscillation. So அப்ப damped oscillation இருக்கு, undamped oscillation பண்ணோம் அப்படின்னா என்ன பண்ணோம் அப்படின்னா, here the energy is losses. So what is the amount of energy is losses in this oscillation? We separate that energy to this wave, it can oscillate like this. So this is called undamped oscillation. Okay, so this is called damped oscillation and is called undamped oscillation. Due to the loss of energy, it is like that. So we are supplying that energy, it will oscillate like this. So this is called the damped oscillation and this wave is called undamped oscillation.